In this video, you will learn about square roots. Now, a square root is basically the opposite of squaring a number. So let's show the similarities. Here we have 0 squared. That means 0 times 0. Right? And 0 times 0 is going to be 0. 1 squared is the same thing as 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16, and etc. Now, the square root is the opposite of squaring something. So if I said the square root of 0, what we're asking is what number squared gives me 0? Well, look, 0 squared is 0, so my answer is 0. Now, what about the square root of 1? The square root of 1 means what number squared gives me 1? Well, look, 1 squared is 1, so the answer is 1. Now, what about the square root of 4? This is asking what squared gives me 4? Well, looking here, we see that 2 squared is 4, so the answer here is 2. Now, what about the square root of 9? That's asking what squared gives me 9. Looking over here, we see that 3 squared is 9, so my answer is 3. The square root of 16 is asking what squared gives me 16, which is going to be 4, because 4 squared is 16. So the symbol we use for the square root is going to be right here, and then whatever's inside, we're asking what squared gives me that number. Now, something to be aware of. When we were asking what squared gives me 1, or what squared gives me 4, or what squared gives me 9, there's actually two different answers. Because negative 1 squared is the same thing as negative 1 times negative 1, which is also positive 1. So when I ask what squared gives me 1, it could be a positive 1 or it could equal a negative 1. And that's because a negative 1 squared would also give me 1. So looking at the square root of 4, that's asking what squared gives me 4. So yes, positive 2 gives me 4, but also negative 2 squared would be 4 as well, because negative 2 times negative 2 would be a positive 4. So this could also be a negative 2. Same for all of these. This could be a negative 3, this could be a negative 4, etc. So there's technically two different possibilities for a square root, but when we're working with square roots, we're typically only concerned with the positive numbers. Alright, so for our purposes, unless stated otherwise, we can assume that we're working with the positive numbers. And the positive numbers, there's a term for that, and that is called the principal root. So principal root. So that just means that we want the positive number. So if I said find the principal root of, let's say, square root of 100. Alright, the square root of 100 is asking what squared gives me 100. That's going to be 10, because 10 squared is 100. So the principal root is 10, which means we're not concerned with the negative 10. We just want to know the positive number. Alright, so as I stated, we're going to be typically concerned with just the principal root. Now, something to be aware of. If we are asked to find the square root of, let's say, negative 1, what this says is what squared gives me negative 1. Well, let's think through this. We might think first maybe a 1, but we check that and we get 1 squared gives me a positive 1. So then you might think, okay, maybe it's a negative 1. So negative 1 squared would still be a positive 1. Okay, nothing squared would give me a negative number. So because of that, we cannot have a square root of a negative number. We call this imaginary, all right, or not real, okay? So for our purposes, we're just going to leave it like this, but as you further your studies of mathematics, we can actually do some things with imaginary numbers. But for now, we're just going to leave it like this, and if you have the square root of any negative number, we will say that that is imaginary. So if you have the square root of a negative 100, okay, that is also imaginary. All right. Now that's different than, let's say we had a negative square root of a positive 4. Okay, this one would actually have an answer because the negative is on the outside. So I do the square root of 4 first. The square root of 4 is 2 because 2 squared is 4. So that's going to be a 2, and the negative is on the outside. So my solution is going to be a negative 2. So if you had a negative square root of, let's say, 49, the square root of 49 is going to be 7 because 7 squared is 49. And then put the negative on the outside, that's going to be a negative 7. So we've dealt with squares and square roots that are perfect squares. So we've done like, square root of 25 or square root of 36, which have integers as answers, right? The square root of 36 is going to be 6. The square root of 25 is 5. But what if it's something in between? So maybe we're trying to find the square root of 27, for example. So to find this, we can estimate just in our heads by seeing what two numbers does the square root of 27 lie between. All right, well, thinking through, if you look at the number 27, 27 is between the perfect squares of 5 squared, which is 25, and 6 squared, which would be 36. So 27 is between those two numbers. All right, so we see that typed up over here. And if these numbers are in this order, 27 is between 25 and 36, then the square root of them will also have the same order, where the square root of 27 is also between the square root of 25 and the square root of 36. Well, the square root of 25 is 5, and the square root of 36 is 6, because 5 squared is 25 and 6 squared is 36. So I know that the square root of 27 must be between 5 and 6. So it's going to be 5 point something. Well, notice 27 is closer to the 25 than to the 36. All right, so we know that our answer is going to be closer to 5 something, so 5 point something. So we can estimate this to be maybe around 5.2 or 5.3 because it is closer to the 25 than the 36. Okay, let's try another one. So we have the square root of 90, and we are told to determine what two numbers does this fall between. So the square root of 90, we need to think through the perfect squares that would be on either side of 90. So if I do 9 squared, I would get 81. If I do 10 squared, I would get 100. All right, so I know that 81 is smaller than 90, and 90 is smaller than 100. So 90 is in between those two numbers. So if I take the square root of everything, this order would also be true. Well, the square root of 81 is 9, the square root of 100 is 10, so I know that the square root of 90 must be between 9 and 10. And if you're trying to estimate, you want to determine which one would it be closer to. Looking back at the 81, 90, and 100, 90 is pretty much in the middle, right? 81 plus 9 is 90, 90 plus 10 is 100, so it's almost in the middle, so I can estimate this to be approximately 9.5. Now, continuing our conversation of radicals and square roots, we need to know how to simplify different expressions. So for example, if we had the square root of 25 plus the square root of 100, what would this equal? Well, the square root of 25 is asking what squared gives me 25. And that's going to be 5, right? Because 5 squared is 25. And then the square root of 100 is asking what squared gives me 100. And that's going to be 10, because 10 squared is 100. So I have 5 plus 10, which equals 15, and that is my solution. Now what if you had something a little more complicated? Maybe we had 2 plus 3 times the square root of 49. Now remember, if you have multiple things like we do here, make sure you follow the order of operations. And radicals, notice, will fall on the same level as exponents. So I do the radical first, and then I can do multiplying, dividing, adding, and subtracting. So notice, by the way, this 3 in the front of the square root, this means multiplication. Just like if a 3 was in front of a variable, like 3 times x, for example, you'd write that as 3x without a multiplication sign. So this means multiply, but before I multiply, I need to take care of this radical, or the square root. So the square root of 49 is asking what squared gives me 49. And that's going to be 7, because 7 squared is 49. So I have 2 plus 3 times 7. Now I can multiply next to get 21, and then I add to get 23. So my solution is 23. One more example with simplifying. Here we have this seemingly difficult problem. We have 2 minus 3 times the square root of 4 times 25 divided by 4 times the square root of 36. So when I do this, remember I want to do order of operations. And with exponents, we also have radicals in there. All right, so looking at the radical, or the square root, we see inside the top one, 4 times 25. Well, 4 times 25 is 100. So I have the square root of 100 up there. And then on the bottom, the square root of 36 is asking what squared gives me 36. And that's going to be 6, because 6 squared is 36. So on the bottom, I have 4 times 6. Now on the top again, we have the square root of 100. So the square root of 100 is asking what squared gives me 100. And that's going to be 10, because 10 squared is 100. All right, now from here, I can work with the numerator and denominator separately, and I see multiplication would come next. So let's do that. On the top, we have 3 times 10, which is 30. So I have 2 minus 30 on the top. In the bottom, 4 times 6 is 24. And then on the top, we can subtract 2 minus 38 to get negative 28, and that's over 24. I can divide the top and the bottom by a 3, divide by a 4. 28 divided by 4 is 7. 24 divided by 4 is 6. So I have negative 7 over 6. So this would be my simplified form of the original expression.